Imagine standing in the heart of a vast, open field on a cloudless night, where the sky unfurls above you like a velvet tapestry adorned with billions of twinkling stars. A gentle breeze carries the crisp chill of the night, and in the profound silence, you hear the faint whispers of the cosmos. Those flickering lights, though they appear as mere spakes to your eyes, are colossal furnaces, stars that have burned for millions or even billions of years, each one holding within it a tale of creation and destruction. But among this celestial symphony, what is the mightiest force of all? Is it the blazing inferno of a supernova, or the all-consuming darkness of a black hole? Could it be the invisible energy pushing galaxies apart, or the relentless flow of time that erodes everything in its path? This question is not merely a challenge to our intellect. It is an invitation to step beyond the familiar confines of Earth and explore a realm where the very concept of strength is redefined. In human terms, strength is often associated with tangible, measurable feats: a weightlifter hoisting hundreds of kilograms, a machine shattering mountains, or a ruler commanding an empire. Yet, in the grand theater of the cosmos, these measures seem trivial, almost insignificant. The most powerful punch a human can deliver would not disturb a single speck of cosmic dust. The most advanced machinery humanity has built is but a faint whisper in the majestic chorus of the universe. The cosmos is not a stage where the strongest stand atop a podium. It is an intricate web where forces intertwine, support, destroy, and rebirth one another in an eternal cycle. To identify the mightiest entity, we must first redefine what strength means in the boundless expanse of the universe. Is it the capacity to annihilate everything into ash, or the delicate balance that sustains the intricate dance of countless elements? Is it the dazzling brilliance of an explosion, or the silent, unstoppable force of time? Let your mind drift into the vastness of space, where stars glimmer like candles in an endless night. Picture the soft rustle of cosmic wind, streams of hydrogen and helium flowing silently, clouds of dust faintly glowing with distant light. In this realm, strength is not just explosive energy or overwhelming gravity. It is also patience, endurance, and the remarkable ability to create life from what seems lifeless. Our journey begins with one of the most haunting images in human imagination: the black hole, a place where strength reaches its ultimate extreme, where light is imprisoned, and time itself seems to stand still. Imagine yourself adrift in the infinite void of space, surrounded by an all-encompassing darkness punctuated only by the faint glimmers of distant stars. Suddenly, you feel an invisible pull, as if the universe itself is tightening its grip around you. The light around you begins to fade, and the stars stretch into spiraling streaks, like whirlwinds of radiance being drawn into an abyss of absolute darkness. This is a black hole, the ultimate symbol of unstoppable power, where even light, the fastest entity in the universe, bows in submission. Black holes are far more than scientific curiosities. They are cultural icons, featured in science fiction as gateways to oblivion or eternal mysteries. But what exactly is a black hole? Contrary to its name, it is not an empty void or a literal hole in space. It is a real, physical object with such immense density that it defies all conventional understanding of matter and energy. To form a black hole, a massive star, often tens or hundreds of times the mass of our Sun, must exhaust its nuclear fuel. When this happens, the star's core can no longer withstand its own gravitational pull. In a cataclysmic moment, the core collapses, triggering an explosive supernova that blasts the star's outer layers into space. What remains is compressed into an unimaginably dense point, warping the fabric of space and time around it. This creates a region where gravity is so intense that nothing, not even light, can escape a boundary known as the event horizon. From a safe distance, a black hole behaves like any massive object, obeying the laws of gravity. You could orbit it, much like Earth orbits the Sun, but cross the event horizon, and there is no return. Time slows to a crawl, light stretches into deep red wavelengths, and the familiar laws of physics begin to unravel. To an outside observer, you would appear frozen at the edge of the event horizon, trapped in an eternal moment. Yet, from your perspective, time flows normally as you plunge into the unknown. Far from being mere agents of destruction, black holes play a pivotal role in the cosmos. Astronomers have discovered that most galaxies, including our Milky Way, harbor supermassive black holes at their centers, with masses millions or even billions of times that of the Sun. These cosmic giants act as anchors, orchestrating the orbits of hundreds of billions of stars in a delicate cosmic ballet. Without them, galaxies might dissolve into chaos. Thus, black holes, often seen as symbols of annihilation, are also the architects of cosmic order. The power of black holes extends beyond their gravitational might. They pose profound philosophical questions. If light cannot escape, does a reality exist within a black hole? Is everything that falls into it erased forever? Or does it persist in some unknowable form? This is the heart of the black hole information paradox, one of the greatest unsolved mysteries in modern physics. Einstein's theory of general relativity describes how black holes bend spacetime, but at their core known as the singularity, where density becomes infinite, all equations break down. Black holes are both a mirror reflecting the limits of human knowledge and a beacon igniting our relentless curiosity. Imagine standing before a black hole, not with fear, but with burning curiosity. In its silent darkness, you hear the universe's whispers, as if it is sharing secrets from the dawn of time. A black hole is not just a physical entity, but a symbol of quiet, overwhelming power, a force that needs no light or sound to command the cosmos. Now, shift your gaze from the silent darkness of black holes to a spectacle of dazzling light and explosive energy. Picture a star, a modest speck in the night sky, burning steadily for millions of years. Then, without warning, it erupts in a supernova, a cosmic explosion so brilliant it outshines an entire galaxy, its light overpowering billions of stars. This is a supernova, not just the death of a star, but a final, grandiose performance, a cosmic aria echoing across the universe. A supernova occurs when a massive star exhausts its nuclear fuel, unable to resist its own gravity. The star's core collapses in a fraction of a second, unleashing a colossal burst of energy equivalent to the sun's entire lifetime output. Compressed into mere moments, the light from this explosion can outshine its host galaxy, like a celestial beacon piercing the darkness. The shockwave obliterates everything within dozens of light years, shredding the star's outer layers and forming vibrant nebulae, cosmic clouds that glow like celestial artworks. Yet, the true magic of a supernova lies not in its destructive power, but in its creative legacy. In the crucible of the explosion, heavy elements like carbon, oxygen, iron, gold, and uranium are forged elements that cannot form in the steady fires of a star. These are scattered across space, becoming the building blocks for new stars, planets, and even life itself. Pause for a moment to consider this. Every carbon atom in your body, every oxygen molecule you breathe, was born in the fiery heart of a supernova, billions of years ago. In a profound sense, we are all children of these cosmic explosions, woven from the ashes of ancient stars. Imagine standing on a distant planet, watching a supernova ignite the cosmic horizon. Its light blazes like an eternal flame, a fusion of destruction and creation, ferocity and tenderness. A supernova gives everything to the universe, holding nothing back, its energy and matter seeding the cosmos for future generations. If black holes are the devourers, supernovae are the givers, their final flames illuminating the heavens before fading into eternity. If a supernova is a star's fiery farewell, imagine a phenomenon so powerful it lights up not just a galaxy, but entire swaths of the universe. These are quasars, the cosmos's most luminous beacons, shining with the intensity of hundreds of galaxies combined. Picture yourself drifting through space, surrounded by endless darkness, when a faint speck of light appears in the distance. As you approach, it erupts into a blazing inferno, so bright it overwhelms even the most powerful telescopes. Discovered in the 1960s, quasars were initially mistaken for ordinary stars due to their point-like appearance, but their true nature stunned astronomers, Quasars are powered by supermassive black holes at the centers of galaxies, voraciously consuming matter. As gas, dust, and even stars spiral into the black hole's accretion disk, they collide and generate temperatures of millions of degrees, emitting light and energy that travel billions of light years. A single quasar can outshine trillions of stars, a cosmic lighthouse illuminating the early universe. Imagine a swirling disk of matter, like a galactic storm, where material is torn apart and ignited into radiant beams. If our sun were to become a quasar, Earth would be incinerated instantly, and its light would dim the entire Milky Way. Yet, quasars are more than displays of raw power. They are time capsules. Their light, emitted billions of years ago, reaches us as a message from the universe's infancy, offering insights into the formation of galaxies. In their brilliance, quasars reveal a paradox. A black hole, the epitome of darkness, generates the universe's brightest light. This interplay of destruction and creation challenges us to rethink what strength truly means. Now, step beyond the dazzling light of quasars into a realm of mystery where power needs no form or visibility. This is dark energy, an enigmatic force comprising nearly 70% of the universe's energy, yet invisible and intangible. Picture the universe as a vast tapestry, with galaxies as vibrant patterns, stretching ever wider. What drives this expansion? Dark energy, a silent force shaping the cosmos's fate. Discovered in the late 20th century, dark energy revealed itself when astronomers noticed that the universe's expansion was accelerating, defying expectations that gravity would slow it down. Like an unseen hand pushing space apart, dark energy drives galaxies away from each other. It interacts with neither light nor matter, detectable only through its influence on cosmic expansion. Imagine standing by a still lake, watching ripples spread without knowing their source. Dark energies, that unseen breeze, its effects rippling across the cosmos. Comprising roughly 68% of the universe, dark energy overshadows the 5% of ordinary matter, stars, planets, and us, and the 27% of dark matter. While dark matter binds galaxies with gravity, dark energy drives them apart, a silent tug-of-war shaping the universe's structure. Some theories link dark energy to Einstein's cosmological constant, once dismissed as his greatest blunder, but later vindicated by evidence of accelerated expansion. Dark energy might lead to a big rip, tearing apart galaxies, stars, and atoms, or a big freeze, where the universe cools into a lifeless void. Invisible yet omnipotent, dark energy reigns as a king without a throne, commanding the cosmos without ever revealing itself. While dark energy pushes the universe apart, another invisible force holds it together. Dark matter, comprising 27% of the cosmos. Imagine gazing at a spiral galaxy, its stars sparkling like jewels. What you see is only the surface. Dark matter, invisible and intangible, forms the scaffolding that prevents the galaxy from flying apart. Like an unseen ocean, it supports the cosmic ships of stars and gas. Dark matter's existence was inferred in the 20th century, when astronomers like Fritz Zwicky and Vera Rubin noticed that galaxies moved faster than their visible mass could explain. Zwicky's observations of the Coma cluster in the 1930s and Rubin's studies of galactic rotation in the 1970s revealed a hidden mass, dark matter exerting gravitational influence. Without it, galaxies would disintegrate under their own motion. Dark matter also seeded the universe's structure, its gravity drawing gas together to form stars and galaxies after the Big Bang. Though it does not emit or reflect light, dark matter's presence is felt through its gravitational pull. Experiments in underground labs and particle accelerators like CERN seek its nature, hypothesizing particles like WIMPs or axions. Yet, dark matter remains a cosmic phantom, a silent giant shaping the universe without ever stepping into the light. Gravitational waves, the universe's cosmic symphony. Picture space not as a static void, but as a fluid lake, rippling with every cosmic event. These ripples are gravitational waves, predicted by Einstein in 1916 and detected in 2015 by LIGO. Imagine hearing a faint hum, not through air, but through the fabric of spacetime, caused by two black holes colliding over 1 billion light-years away. Gravitational waves arise when massive objects, like black holes or neutron stars, move or merge, disturbing spacetime, like ripples from a stone tossed into a pond. These waves travel at light speed, stretching and compressing space. When they reach Earth, their effect is so subtle it shifts detectors by less than a proton's width, a testament to human ingenuity. Each wave carries a story of cataclysmic events, offering a new way to observe the universe, unhindered by dust or distance. Imagine hearing the fleeting chirp of a gravitational wave, a note in the universe's symphony, narrating tales of ancient collisions. These waves reveal just physical events, but the dynamic nature of the cosmos, a universe that sings through its vibrations. If black holes consume white holes, their theoretical opposites create. Picture a region of space, not absorbing, but emitting matter and light, like a fountain bursting from nothingness. In general relativity, white holes are mathematical counterparts to black holes, where nothing can enter, but everything can escape. They remain hypothetical, with no observed evidence, yet they spark imagination. Some theorize white holes as the final stage of evaporating black holes or portals to other universes. Imagine standing before a white hole, watching light and matter pour forth, a cosmic spring of creation. Though speculative, white holes remind us that the universe thrives on possibilities, urging us to dream beyond the known. Rewind to the ultimate beginning, the Big Bang, 13.8 billion years ago, when all space, time, matter, and energy were compressed into an infinitesimal point. In a fleeting instant, this point expanded, not into space, but creating space itself. The universe ballooned in a phase called inflation, laying the foundation for all we see today. Picture that moment, a searing, chaotic cosmos where pure energy condensed into particles, then atoms. As it cooled, the first light, the cosmic microwave background emerged, a snapshot of the Big Bang still visible today. The Big Bang is not just an event, but the origin of all stories, from stars to life. It challenges our understanding, as physics falters before that singular moment, leaving us to ponder what, if anything, preceded it. Amid these cosmic titans, one force stands supreme: time. Imagine it as an invisible river, flowing relentlessly through the universe. It needs no light or energy, yet it outlasts all. Stars fade, black holes evaporate, but time marches on, eroding everything in its path. Picture standing on a hill, gazing at the ruins of ancient cities, their stones worn by wind and rain. Time requires no fanfare, yet it shapes all. The birth of stars, the evolution of life, the decay of civilizations. Einstein showed that time can stretch or contract, yet it never stops. Near a black hole, a minute might span years, but time remains unstoppable, the ultimate force that bows to no one. In this vast cosmos, a small but extraordinary force shines: human intelligence. Imagine our ancestors, vulnerable on the African savannah, armed not with claws, but with minds that observed, imagined, and questioned. This intellect built tools, harnessed fire, and crafted civilizations, eventually turning its gaze to the stars. Intelligence lacks the raw power of a supernova or the gravity of a black hole, but it alone can comprehend the universe. Through telescopes, particle accelerators, and bold theories, we unravel cosmic mysteries. Our knowledge, passed through generations, defies time's erosion, our signals carrying humanity's story to distant stars. Yet, even intelligence faces an inevitable end: the heat death of the universe. Picture a distant future where stars burn out, black holes vanish, and energy disperses into a cold, uniform void. No explosions, no chaos, just a gradual fading, like a candle burning its last wax. The universe reaches absolute zero, motion ceases, and all light fades. This quiet end reminds us that no power is eternal, yet it challenges us to find meaning not in permanence, but in the fleeting brilliance of existence. In the moments we shine, before the darkness falls. After traversing the universe's mightiest forces from black holes to supernovae, dark energy to time, intelligence to the heat death, we see no single champion. The universe is a symphony, each force a note in an eternal melody. Strength lies not in domination, but in harmony, in the interplay of creation and destruction, light and dark. Stand beneath the night sky, listening to the universe's whispers. Every star, galaxy, and speck of dust tells a story of power and existence. The question of the strongest force yields no single answer, but a gift, the human drive to seek, understand, and become part of the cosmos's timeless song.